Under the freezing skis of the Ural Mountains, a different kind of factory came to life, noisier, rougher, and far more desperate. Sparks bounced off concrete floors that had frozen solid during the night. Diesel fumes mixed with coal smoke from makeshift furnaces, forming a haze that hung under the rafters. Workers in quilted jackets rubbed their hands against iron stove pipes before climbing onto tank hulls still coated in frost. When a door opened, a gust of cold air swept across the workshop, carrying the smell of welding flux and unburned diesel. Chelyabinsk tractor plant became known as Tankograd, the tank city. Before the war, it built tractors and engines for farms. Now it built the machines that kept the Red Army moving: T-34s, KV heavy tanks, self-propelled guns, and later the S-series heavy armor. The place ran on stubbornness and cold air, and the silent understanding that every tank that left the factory might be the difference between a German breakthrough and Soviet survival. Tankograd did not appear out of nowhere. It was the child of an industrial evacuation that stretched the limits of human endurance. As the Wehrmacht swept across Ukraine, Belarus, and the western districts of Russia during the second half of 1941, the Soviet state dismantled 1,523 factories and sent them east. It was more than machines. It was engineers, designers, tool makers, clerks, cooks, families, drafting tables, foundry molds, even livestock. Trains rolled day and night. A railway engineer later said the tracks glowed red from the weight of steel, not because they truly heated, but because the freight never stopped. The road to the T-34 and its diesel heart. They began long before Tankograd, with two designers who refused to build another fragile, high-maintenance machine. Mikhail Koshkin and Alexander Morozov had inherited the BT fast tank, a design with speed but very little protection. The Red Army wanted something that could outrun, outlast, and outfight German armor. Koshkin argued for a diesel engine even before the purges cleared out many of the design bureaus. He believed gasoline tanks were rolling fire hazards, and he insisted that diesel would save crews' lives. Many officers considered diesel unrealistic. The engine was heavy, complex, and notoriously difficult to manufacture in large numbers. But Koshkin and Morozov pushed ahead. In the winter of 1939, they test drove their experimental A-32 and A-20 prototypes from Kharkov to Moscow, a journey of more than 1,000 kilometers, across snow, mud, and frozen rivers. They wanted to show the military that their tank could survive anything. The crew nearly froze, but the diesel engine kept rumbling. When they reached Moscow covered in road dust and frost, they had proven their case. At the center of the T-34 sat the V2 diesel, a 12-cylinder aluminum engine delivering about 500 horsepower. The V2 began life as an aircraft-derived concept built for the BT-7. Engineers worried that casting such a large aluminum block in wartime conditions would be impossible. Early V2s cracked pistons and seized bearings. Morozov's team responded with simplification. Thicker walls in stressed areas, fewer machining passes, and castings designed to tolerate imperfect alloys. By 1942, the V234 variant could run hundreds of hours if crews maintained oil changes properly, which was more than acceptable for wartime service. German tanks relied on gasoline Maybach engines. The Panzer IV used the HL-120 with about 300 horsepower. The Panther and Tiger carried the larger HL-230 with roughly 700 horsepower, a complex, high-temperature engine requiring precise tolerances and high-octane fuel. Panther crews described engine compartments so hot that gloves were required for even simple checks. Dust and mud clogged the carburetors. Oil pumps complained in cold weather. A Soviet test report noted that the Panther hates bad roads and worse fuel. Soviet testers, in a moment that later sounded like myth, really did pour sand into the V-2's air intake. If the engine survived, the configuration stayed in production. It was not a matter of cruelty. It was a direct test for battlefield conditions where filters tore, hoses cracked, and dust storms soaked the steps. The T-34's iconic shape emerged from careful engineering. Its armor sloped at angles close to 45 degrees, giving 60 millimeters of steel the protective strength of nearly 80 millimeters of vertical armor. German gunners noted that their shells bounced like hammers hitting a bell at medium range. The F-34 76-millimeter gun fit inside a two-man turret that forced the commander to serve as gunner. It was cramped, but the design kept production fast. When the T-34-85 arrived in 1944 with a larger turret and an 85-millimeter gun, the commander finally had his own seat, raising combat effectiveness dramatically. Metal ore and scale. Tankograd existed because the Soviet Union moved everything east as the Germans closed in. Between August and December 1941, thousands of freight cars carried machinery from Kharkov, Leningrad, Rostov, and other industrial centers to the Urals, Siberia, and Kazakhstan. Iron ore arrived from Magnitogorsk, pig iron from Kuznetsk and Nizhny Tagil. When the Nikopol manganese basin fell, which was essential for high-quality armor steel, supplies shifted to Georgia's Chayachuri mines and smaller Ural deposits. The sudden change in manganese content forced metallurgists to alter formulas on the fly. Some early plates were brittle. Others were too soft. Armor quality dipped in 1942, then rose again once Ural manganese stabilized alloy content and new heat-treating regimes were introduced. Factories melted anything they could find. Old rail lines, farm tools, worn-out tractor frames, even church bells removed from empty villages. A senior metallurgist joked, "Every bell tower on the frontier is now part of a tank." Tankograd's foundries fought the cold as fiercely as the workers fought fatigue. Pouring steel in temperatures below zero created immediate cracking. Engineers improvised by building brick heating pits under the molds, heating them with scrap wood and any fuel they could find. The glow of these makeshift furnaces lit the foundry floor at night like a forest of small suns. By the winter of 1942, Tankograd's halls ran almost non-stop. Workers slept under workbenches. Many were teenagers who had completed crash courses lasting only 6 weeks before being thrown onto the assembly line. A welder named Zenaida, who had lost her husband at Leningrad, welded 16 hours a day. She said, "I put my grief into the seams. Every tank carried a piece of it." Her words became a quiet legend inside the factory. One morning, a newly assembled refused to start. The engineer in charge slammed the hatch, circled the hull, and kicked the track. The V2 coughed, sputtered, and roared to life. The entire workshop laughed, briefly forgetting the war outside. The Soviet versus German production gap. Soviet production outpaced German production because it embraced simplicity, standardization, and brutal pragmatism. In 1941, the USSR built about 1,800 T-34s. In 1942, output jumped to more than 12,000, roughly 7 times the previous year. 1943 reached more than 15,000, about 1/4 more than 1942. Even in 1944, with the front pushing west, factories built close to 14,000. Germany built about 6,000 tanks in 1943 and around 9,000 in 1944. These totals included Panthers, Tigers, Panzer IVs, and assault guns. They could not match the Soviet pace because each German vehicle required far more machining time and used alloys Germany had trouble producing in bulk. Labor time told the same story. A V required roughly 20,000 man-hours. A Panther required 3 to 7 times more. A Tiger demanded even more precision, specialized tools, and highly trained machinists. A captured German engineer later said, "The T-34 is not elegant, but it is practical. It is an industrial weapon. We cannot match its numbers." How the Soviets scaled production. Soviet designers aimed for something the Germans never fully embraced: a tank that embodied the minimum number of parts needed to survive the Eastern Front. Every year, the T-34 became simpler to build. Instead of precision-machined gear housings, factories cast large sections. Instead of complex bevel gears, they widened teeth so lower-grade steel could still carry loads. When glass optics ran short, commanders made do with simpler sights. When alloying elements disappeared, metallurgists reformulated armor to keep thickness and hardness within reasonable margins. Standardized jigs and gauges spread across factories. When Kharkov fell to German forces, its blueprints traveled east to Nizhny Tagil and Chelyabinsk. The design bureaus held meetings on the shop floor, allowing draftsmen to watch how their drawings behaved in real metal. Engineers broke down machining steps to cut minutes off each operation. By 1943, one assembly line measured takt time in minutes per station rather than hours. Quality dipped sharply during the turmoil of the evacuation. Welders used scrap electrodes. Machinists improvised missing gauges with wooden templates. But by late 1942, the system stabilized. Many of the improvements came from unexpected sources. Lend-Lease brought American machine tools, micrometers, milling equipment, and precision jigs that dramatically improved part interchangeability. A machinist in Nizhny Tagil said, "The tools from America were like a violin after a wooden spoon." The supply chain also became more robust. Lend-Lease delivered tin, copper, rubber, aluminum, and high-grade rail steel through Iran and Murmansk. Even Soviet aluminum benefited from the campaign to melt every scrap the country could find. Schoolchildren organized drives to collect aluminum pots and pans. The V2's aluminum block depended on this national recycling effort. Engines in contrast. The V2 diesel defined the T-34's character. It gave the tank its low silhouette, good torque, and respectable speed. Diesel burned cooler than gasoline, lowering fire risk. A Soviet tanker once said, "The engine smells like a tractor, but climbs like a bear." German HL-230 engines gave Panthers and Tigers impressive horsepower on paper. But the Panther weighed over 44 tons, nearly twice a mid-war T-34. Its gasoline burned hot. Radiators and fans struggled to keep temperatures stable. Dust-heavy roads clogged carburetors. Bearings failed under extreme stress. Fuel consumption was roughly double that of a T-34. At night in winter, German crews often drained coolant to prevent freezing. Soviet crews lit fires under oil pans or used steam trucks to preheat engines. In field repair tests, a Soviet team could swap a V2 in 6 to 8 hours with a gantry and chains. A Panther engine swap could take a full day with a dedicated crane. Earlier Soviet tanks like the BT series used aircraft-derived gasoline engines and burned readily when hit. Koshkin's insistence on diesel reversed that legacy. Heavy tanks like the KV-1 and IS-2 used variants of the V2 tuned for torque, showing how flexible the engine family truly was. Other Soviet tanks in the line. The KV-1 rolled out of nearby factories, trading speed for armor. Its massive hull and thick plate absorbed enemy fire, letting T-34s flank. When weight became too much, the KV-1S introduced a lighter, more agile version. Later, the IS-2, armed with a 122mm gun, broke German defensive lines and destroyed bunkers with high-explosive shells. The IS's penetrating armor and powerful gun terrified German infantrymen, who called it the Beast. Self-propelled guns filled other roles. The Su-76, light and open-topped, doubled as an artillery tractor. The Su-85 and Su-100 mounted long-barreled guns on the T-34 chassis to hunt Panthers at distance. Using the same basic hulls simplified repairs and supply. Tankograd built close to 40% of Soviet tanks and nearly half of self-propelled gun chassis. It also produced thousands of Katyusha launchers. Many rode on American Studebaker US-6 trucks, which Soviet drivers praised for reliability and soft suspension. Marshal Zhukov later remarked, "Without American trucks, we would not have been able to conduct our operations." The Red Army's mobility depended on these vehicles. Guns, armor, and field fixes. The early F-34 gun could knock out a Panzer III at a kilometer. Against larger German tanks like the Panther, crews aimed for flanks or tracks at 200 to 500 meters. The 85mm gun on the T-34-85 changed that equation. Its long barrel and improved optics allowed it to penetrate German side armor at more than a kilometer. Armor composition evolved constantly. High manganese plates gave strength, but shortages in 1942 forced metallurgists to reformulate alloys. Some early plates were brittle. Others resisted penetration, but produced dangerous internal spalling. Heat treatment improved in 1943, reducing spalling and increasing consistency. Crews improvised extra armor with spare track links and steel road wheels welded to the hull. Mechanics repaired transmissions by dropping them onto wooden blocks in the mud, fixing them overnight, and returning the tank to the line the next day. One mechanic said, "We fixed them like horses with broken shoes." Production choreography. Assembly lines moved on wooden skids. Tanks slid from station to station. Inspectors marked cracks with chalk. A white cross meant grinding. A red circle meant reweld. The pace was relentless. Women made up a large share of the workforce. Many machinists were teenagers who learned their trade on the job. Factories cut anything that slowed production. Cast turrets replaced complicated weldments. Periscopes stayed simple because high-quality lens glass was scarce. When gear teeth chipped frequently, designers widened them rather than switch to better steel. The question was always, can it survive the front, and can we build it faster? Fuel, range, and logistics. Carried external fuel drums for extra range. On road, it could travel close to 300 kilometers. Off-road, often half that. Winter stiffened oil, so crews lit small fires under the pan or used steam trucks to warm coolant. Most tanks traveled to the front by rail. The broad Russian gauge allowed heavier loads and simplified logistics. Field depots stockpiled V2 engines and transmissions. The Red Army treated the T-34 as a consumable machine. Crews rarely expected a tank to last beyond a few operations. Replacement mattered more than preservation. How the tanks fought. T-34 battalions advanced in wedges. Radios were scarce early in the war, so flags, hand signals, and prearranged maneuvers guided movement. Wide tracks distributed weight, keeping the tank mobile in mud and snow. German officers were shocked to see T-34s crossing ground where Panzer IIIs bogged down. The early two-man turret strained commanders, who aimed the gun, issued orders, and scanned for threats simultaneously. When the T-34-85 introduced a three-man turret, crew performance improved immediately. The tank remained simple but became tactically sharper. KV-1s blocked roads and absorbed fire. IS-2s destroyed bunkers and tanks with massive shells. Su-76s supported infantry. Su-85s and Su-100s waited in ambush positions to kill Panthers from long range. Design, mindset, and architects. Koshkin and Morozov sought a soldier's tank, rugged, simple, forgiving. Morozov's design bureau embraced the rule that any part which could be removed, simplified, or thickened without hurting function should be. Meetings took place on the shop floor. Engineers watched welders struggle with certain seams and redesigned parts accordingly. Chief Engineer Ivan Trashutin protected the V2 line, ensuring engines remained buildable with local alloys. He balanced power, durability, and manufacturability, an impossible triangle under peaceful conditions, achieved under wartime pressure. Engines versus engines in the field. German HL-230 engines could deliver more raw horsepower, but battlefield conditions punished complexity. Dust ruined carburetors. High compression ratios demanded refined fuel the front could rarely supply. Panther engines overheated easily and required constant attention. The V2 tolerated dirtier fuel and colder mornings. It broke, but it broke predictably. Crews carried spare injectors and filters. In field trials, Soviet mechanics swapped engines with block and tackle rigs attached to birch trees. A Panther crewman reported that after a week on muddy roads, they spent more time cleaning filters than fighting. A Soviet tanker joked, "Our tank eats dirt for breakfast." Numbers across the war. By 1945, total production reached more than 57,000. KV-1 and KV-1S production stayed around 3,000. Is-2 tanks added more than 3,500. Su-76 guns surpassed 14,000. The T-34 chassis supported thousands of Su-85s and Su-100s. The numbers told a story. A design optimized for mass production could flood the battlefield. The German army, by contrast, produced fewer heavy tanks and struggled to replace losses. Panthers and Tigers terrified opponents but broke often and required long repair cycles. Soviet planners summarized the situation simply: quantity is a quality. What it added up to? By 1943, Soviet armor brigades could lose a third of their tanks in a week and still continue fighting. German divisions could not. The Red Army made mistakes, suffered heavy losses, and often paid a high price for tactical errors, but it had the industrial momentum to recover. Tankograd and Willow Run were worlds apart, one modern and orderly, the other freezing and improvised. One used conveyor belts and aircraft jigs. The other welded plates heated by brick ovens. Yet both revealed the same truth. Wars are not only decided by battles, but by engines, steel, fuel, and the willingness of workers to keep machines moving. A strategic result. By 1943, the Red Army outproduced Germany in tanks by roughly 4-1. By 1944, in some categories, the margin reached 5-1. German armored divisions were worn down faster than they could be rebuilt. The T-34 became the machine that made victory possible. Soviet planners said it plainly: our factories were our front line. And in Tankograd, under the frozen roofs of the Ural Mountains, that front line never slept.